Hey, biologists, it's time for Meal and a Murder Challenge. Well, we're going to decide who did it today, a little murder mystery. In order to figure this out, we need to take and realize that a murder has just occurred, simulated, just pretend, and right here in our peaceful little town of Napa, California. As top-notch biology students at Napa High, you have been asked to assist in the investigation of this most unfortunate incident. Central to identifying the individual who committed this crime is identifying where the victim was the day of the crime so that detectives can question the individuals with whom the victim came into contact. An autopsy, which is a study of a dead body, was performed on the victim, which has revealed the victim ate just prior to the time of death. Upon questioning the victim's friends and family, detectives working in the case had learned the victim enjoyed eating at the following restaurants. You might know some of these places. Filippi's Pizza Grotto is a good place. The victim would never eat thick crust pizza from anywhere else. The victim would typically order a pizza with sausage, pepperoni, and bacon. Think about what's involved and what macromolecules are involved in that meal. Papa Joe's Wings. The victim would hang out here while feasting on chicken wings. Oh, delicious. And Via Corona, one of my favorites. The victim loved to go here and eat chips and salsa only. So a forensic pathologist has removed the contents of the victim's stomach for you to analyze in order to determine where the victim had his last meal. So these are the contents of that victim's stomach. And you can see this is what we're testing here. This is our variable in the experiment. We're testing to see whether or not there's protein, carbohydrates, lipids in this last meal. So I put this together complete with experimental groups and control groups. Remember, the control group, it needs to be there. It does not get the variable. The experimental group is what gets the variable. And I have 3 experimental groups and 3 control groups. Here they are. So looking at the first test, here they are, all 4 tests. We're going to perform these on the food item, on the stomach contents, to see if we can test for simple carbohydrates or even complex carbohydrates. Simple carbs are like sugar. Complex carbs are long chain molecules like starches, things that are in corn and veggies, and big molecules like pasta and all kinds of things, fat and protein. So our way to test for protein is to take and homogenize or blend up a food sample. Here it is. And place it into a solution tube with water. When we do this, we're going to add this reagent called burettes. Burettes is an indicator. It's a color that really starts out a little light blue. This light blue then can turn to purple if there's the presence of protein. Let's find out. Here's the control group. It's the control group right here. It says control group right there. And you can see that it's totally clear in blue. This is how it should look. When we add the stomach contents to it, we get, this is the experimental group. Really didn't change purple at all. All right, there's a result for you. Our protocol for the lipid test. Our lipid test looks like this. If we use a paper towel or a brown paper bag, and we can take and put that oil on one side and water on another, we'll see that the oil soaks into the paper bag and the water does too. But when it dries, the oil leaves the paper bag translucent or transparent. You can kind of see through it. So we're going to clean off the surface, let it dry for several minutes, and I've got our results. Let's see if it's wet. If it's wet, it'll dry. The fats are present. If it's wet, it'll dry and just leave the brown paper bag. If the fat is present, it'll let the light shine through the paper. We take a paper towel, we take a little bit of the stomach contents and put it on the paper towel. And then we take some water and drop it on there. I'm going to use a graduated cylinder to do that. I'm going to put that on there as well. Then we just let all of that dry. When it dries, we can see the experimental group, which is this spot right here. You can see it really does kind of show through. I can put my finger behind it, not quite like the paper towel. It is really transparent. But where we put the water, which is over on this side, that water has evaporated and is gone. It really just looks like paper towel that dried. So this is a test positive for lipids. Next, our starch test. We can use iodine. You might be pretty familiar with using iodine on cuts. I have a little bit of iodine here. If you get a cut or you get a shot, sometimes they'll put it on your skin, rub with a little wipey. You'll get a little yellow spot on your skin, and then that'll help disinfect or kill bacteria before they give you a shot, or maybe you have a cut. And so we're going to place it into a solution, into water. You can see the control group on the right-hand side, the yellow. That's how iodine looks. This yellow solution is iodine. This is my control group. What does it look like? This is the experimental group. The experimental group is really dark. We can take and mix it up, holding the test tube. We've got a blue, purple, or blackish color in there. It is not yellow anymore. It looks blue and purple, which is a test positive for starch. Looks like this had starch in it. No protein. Definitely starch. Definitely lipid. Let's try the next test. This is a test for simple sugar. In order to do this test, we have to take the food sample, mix it up, place it into a solution. We're going to take and use this indicator called Benedict's. It's a nice bright blue color. We're going to add some Benedict solution, place it in a hot water bath for 10 minutes. If it changes color, it indicates the presence of sugars. So if it stays blue, no sugar at all. Sugar like the candy, sugar that's sweet, simple sugar. If there's a little bit of sugar, it'll be green. If there's more, it'll be yellow, red, dark brown, red or brown. And let's find out. Here it is in the hot water bath. I'm going to take it out using some test tube clamps. Take a look at the solution. Next to the indicator, it really does look the same. They are both a nice bright blue color. That means that there was no simple sugar. There was starch, which is a complex sugar, but no simple sugar. So now, what's your conclusion? Reviewing the foods in the beginning part, construct a scientific argument which you support your scientific findings in a claim, evidence, reasoning. Sometimes we'll call this a CER. You're going to make a claim. You're going to say the victim's last meal was, pick one of those 3 restaurants. Your evidence can be listed out. For example, there are 4 bullets in your CER. Under evidence, you can say it tested negative for protein. What was another piece of evidence that we tested for starch, lipid, and simple sugar? What were the results? That's our evidence. And then your justification of the evidence. Those are your reasoning. That's your reasoning behind looking at what restaurants are possible. Could be the victim's last meal. We're going to pick from one of those three, and you're going to use the evidence to justify your claim in the first place. Tell me things like sentence starters like, we decided to use this evidence because, this evidence is important because. Say, what's important? Sometimes getting a no result is important. It tells you which of those meals it might be. Sometimes getting a no result is important. And sometimes getting a yes result, a positive result for starch, for example, might give you an example of an idea for what happened up there. Remember to click on Google Classroom under classwork and find the meal and a murder lesson. You can find the CER, or the claim evidence reasoning page. Fill that out using Cami and justify your reasoning. When you click on it, the second page, you need help with your reasoning, really looking at that last R part, the reasoning part. Restate your claim, provide some scientific principles or knowledge. Tell me about what is a carbohydrate, what is a lipid, what is a protein. Provide data from the activity. This tested positive, this tested negative. Wrap up your conclusion with therefore, so, and restate your claim.